Hello world, welcome back to another tutorial. Today we're going to be talking about MTLRenderPassDescriptors. Now these are going to be a little bit more complex than everything we've done in the past, even Phong shading. And the reason is because it leads into the coolest topics. Some of those topics include like shadow mapping. How do shadows work in a video game? Reflections off the mirror, bloom effects, making things shiny like in Zelda Breath of the Wild, deferred rendering, where we can have hundreds of lights in one scene without slowing our game down whatsoever. Or one of my favorites is in a video game when they have God rays coming down from like the top of a building and you can see the dust particles through them. That's freaking epic. More advanced topics, and we're going to need to understand the MTLRenderPassDescriptor in order to do any of those. So what I've done is I've created this episode. It's a little dense, it's got a lot going on, but try to pay attention because it's really important for the future. This is fundamental to understand these advanced techniques. I hope you guys enjoy this episode. Let's get into it. Okay, so this is our current scene. We have a bunch of cool trees, a bunch of cool flowers, a tent. That's awesome. We're going to get back to there in just a second, but for now, I want to point you at our extension renderer right here. So this is our renderer class we made a long time ago, and here's our draw function. Our draw function basically creates this render pass descriptor and then uses that render pass descriptor on the render command encoder. We then go ahead and call render on the entire scene, and then we end the encoding. So right here is where we are defining what the render command encoder is going to be coloring to, this render pass descriptor, which currently is just the view's render pass descriptor. If I click the camera in the bottom of the screen to capture one frame, you'll see here is our output view. If I go to the base command buffer here, scene render command encoder, and click that, you'll see here that this little view actually represents our render pass descriptor. This right here is color at 0 target. Remember I said that we have different color attachments. This is the first color attachment. And then we have a depth texture. Now, we can only have one depth texture on our render pass descriptor, and that's because this is outputted by the vertex shader, and then the drawables are outputted by the fragment shader. But this is going to be our color attachment 0. This is our depth texture. If you want to see a little bit more information about this, go ahead and go down here to our scene render command encoder dropdown. You can scroll down. You'll see these are all the textures and vertex buffers and whatnot that are currently attached. But the one that we care about is the render pass descriptor. You can see we have this 1080 by 720 color and depth texture. If I were to open that up, you'll see here we have color attachment at 0 is this one. You can dive into that one a little bit more. And then also we have the depth texture right there. Now, this render pass descriptor is kind of inferred. We say back in render, I'm going to go ahead and stop it. Back in the render function, we use this view current render pass descriptor on our render command encoder. Now, the render pass descriptor for the view is defined inside of our game view, actually. So when inside of our game view, when we say self.clearColor, self.color pixel format, self.dexstencil pixel format, this is creating those textures for us. If we do not define these, it won't define it for us. If I were to comment out all of the references to depth textures, there would be no depth texture on our render pass descriptor because this is where we are defining that render pass descriptor. I hope that made sense. This is the view's render pass descriptor. Also, I would just like to note that the color attachment at 0 is actually a CA metal layer drawable. This is not a texture. This is not an MTL texture. This is a drawable, meaning the view has this texture, this drawable, ready for you to draw to. And inside of the renderer class, we say command buffer.present view.current drawable. So when we render here, we render to that current drawable that is attached to the render pass descriptor of the view. Now that might not be 100% correct, to be perfectly honest with you, but that's as close as I can come to thinking in the right way. So why am I telling you this? We can draw to things. Wow, we draw to the view. That's amazing. How does that help us with shadow mapping and bloom effects? That doesn't make any sense. Well, how that helps us with is we can write to whatever we want. We don't necessarily need to draw directly to the view's current drawable. We can instead define our own render pass descriptor to draw, say you want a reflection, right? So we have a mirror with a camera pointing at you, and we want to render a mirror on the wall. that mirror is going to need a rendered version of it facing us. So basically what we need to do is call render in this direction, and then we render in that direction so that we get the reflection effect. But we need to call render multiple times during that one frame in order to get the reflection. So today what we're going to be doing is we're going to go into our assets and we're going to create some textures that we can use globally. So right up here at the top in texture types, I'm going to do a new case. I'm going to call this the base color render texture. Okay, and then I'm also going to create the base depth render. So we need two things. We need a color attachment at 0, just like before, just like with our view, and then we need a depth attachment, just like before. So we're going to get it kind of to the place we're at right now, and then we're going to modify it going forward. So I have two textures defined now. I can go back to my renderer class and let's play with these. Let's render, instead of rendering directly to the view, let's render to these textures. So up at the top, what I'm going to do is I'm going to create a private var render pass descriptor, and I'm going to call it the base render pass descriptor. Here's going to be our base render pass descriptor, and then instead down here where we're saying render pass descriptor equals view, get rid of that. We're not going to use that one. Instead, what we're going to use is our own base render pass descriptor. Now we need to instantiate this and create it. So what I'll do is I'll create a private function, private func, and it will be create base render pass descriptor. Now just to point out, we're creating a base render pass descriptor here, but we can create another function that does another pass descriptor. Right after this one, we could basically do this and use another render pass descriptor here, and just keep rendering to different things, and then finally we'll do some current drawable stuff. But we don't need any of that. Let's get rid of it. I got excited. Sorry. We have create base render pass descriptor. Now let's go ahead and call that function, create base render pass descriptor. Of course, the first thing we're going to do inside of our base render pass descriptor is say self.base render pass descriptor equals a new MTLRenderPassDescriptor. Let's create the freaking thing. Now I'm going to put this at the bottom because this obviously won't work. If I were to press play, it's going to blow up. I'll even show you. And what do you know? It blew up because we don't have any render targets. We haven't told it, hey, here's some textures to render to. When you do the draw primitives, we haven't told it what to draw to. So it's like, hey, no targets are set. So what we need to do is we need to create some render targets or textures for our thing to draw to. So what I'm going to do is I'm basically just going to create a texture real quick so that you don't have to watch me code it, and then we're going to talk about it. And there you have it. I've created our base color texture. All I did was took an MTL texture descriptor, used its built-in texture 2D descriptor function. I'm using the main pixel format right here, which is BGARA 8UNorm sRGB or something. But we're using the main pixel format intentionally because we want it to match our view. The width is going to be the renderer screen size, so this is just basically our screen width and height. And then we don't need this map because it's not going to be far away, it's going to be right up in our face. The next thing we do is we just set the texture in our textures. The one that we just created, we just set that texture to that base render texture right there. So now we're able to use this texture globally in all of our objects. So if you had a mirror object, it could use this texture. Now this is how you would create a texture, but there's a couple of other things we need to define in order to create this as a render target. The other thing we're going to need to do is say base texture descriptor dot usage equals. Now usage is really important. If I were to press dot here, you'll see we have pixel format view. We have render target, shader read, shader write. For us, this is a render target, right? We're creating render targets for the base command encoder, or for the base render pass descriptor. So this needs to become a render target. Now we can assign that to our render pass descriptor by going self.base-render-pass-descriptor.color attachments at 0. Look at that. .texture equals, and we're going to use that pointer, so assets.textures, and then we're just going to say base color render, just like so. So we've defined one render target. We need a second render target. We need our depth target, and that's really easy to do. Let's just copy this entire thing, paste right here, and instead of the base color texture, let's do a depth texture. So I'll replace base right here with depth. This is going to be the main depth pixel format. Width, exactly the same. Height, same. This is going to be the depth texture descriptor. And then we're going to need to set the texture. Make sure you get all of these. Depth, render, and then this will be the depth texture descriptor, like so. So now we've created a base depth texture, and you'll notice that when I assign this to the render pass descriptor, I don't say color attachments, I just say depth attachment, because there's only one depth attachment. Okay, only one. And we'll say that's asset at textures dot base depth render. And make sure you say dot texture here. So this is the depth attachment dot texture. Now what's nice about this is we're basically setting the textures of these two values to a pointer. So these are going to be a globally available texture. We can use these anywhere. Now the depth texture is a little different. This is going to need to be declared as private. So we can say depth texture descriptor dot storage mode equals dot private. Now the reason it's private is because we don't want it accessible to the CPU. We only want it accessible to the GPU. So as you can see, the resource can only be accessed by the GPU, and that's because it's the depth buffer texture. There's other reasons. I'm not going to get into them, but we've defined our two textures. We have a base color texture and a base depth texture. We have a render pass descriptor defined. And if I were to go ahead and press play, let's see what this looks like. Oh no, what happened to our game? It's not working. Actually, it's working just fine. It's working great. You just can't tell because we're not drawing to the view anymore. We're drawing to textures. Let's go back into our camera and look at what's going on behind the scenes. So as you can see, there's our scene. It hasn't gone anywhere. Don't worry about it. Let's open up the base command buffer, go into our scene render command encoder, and now you'll see that this is not a drawable anymore. First of all, this is just a texture. And this is just a depth texture. These are exactly the same as before, except now we're using textures instead of the view. And if I were to go down in here, show you just to prove the render pass descriptor, we have now two textures. We're not doing the MTLCA drawable. This is a texture now, and this is a texture. These are globally available. Like I said, you have a mirror object, you want to reflect a scene, bam, throw this on the mirror. You have a portal, bam, throw this in a portal somewhere. But in our case, we actually do want to render out to the screen. Really what that has to deal with is using something called a blit command encoder. Now what a blit command encoder is it's basically just a really fast way of using the GPU to copy from one place to another place. I need to copy this texture into this texture. That's it. That's what a blit command encoder does. You can also do like regions and whatnot. But what we're going to do is we're going to use the blit command encoder to copy from our texture that we've drawn to the view's current drawable. So right here, what we'll say is we'll say let blit encoder equal, we're going to use this command buffer, just like we're creating a render command encoder with the command buffer. We can also do command buffer dot make blit command encoder, and bam, we have something we can use to copy data from one place to another. It doesn't have to be textures. This could be data. If you have just a big array of something, you want to copy it somewhere else really fast using the GPU, use a blit command encoder. But in our case, we don't need to do that. And we can just say blit encoder dot copy. As you can see, we get a bunch of copies. And the one that we want is the texture to texture. Make sure this says source texture, texture, destination texture, texture. So copy from to. We need two textures. Well, we have those. We have our assets.textures at dot base color render. Oh, base color render. Remember, this is a global texture. And we want to copy that to our views. So we'll say view.currentDrawable.texture. Now, I get this error. If you get this error, that's because you need to go into your project files and up the deployment target. So I'm going to just set this to the newest one, which is 11.3, and now that error should go away. And of course, before I forget, we did a copy function with an encoder. So what we need to do is we need to say blit encoder.end encoding to let it know that we're not copying anything anymore. And just so that we understand what's happening, I will say blit encoder.label equals, this will be the view display copy encoder, just so we can kind of see what's happening there. I'm gonna go ahead and press play and see what this looks like. Now, I expected this error. I totally forgot about it, but I expected it. This error that's coming up is saying the destination texture must be a frame buffer texture. Now right here we're using the view's current drawable as the destination, so we need to go modify the view's current drawable inside the game view. Like I said at the beginning, this is controlling that drawable. So all we need to say right here is self.frame buffer only equals false. We need to make it not a frame buffer, and go ahead and press play. Now it should work. And we're back to where we started. Look at this. This is our view. Everything's running just fine. It's still smooth. Let's go ahead and jump back into our camera and go look at what's happening behind the scenes. So we have our base command buffer. Let's open it up. Now we have two things. We have a scene render command encoder and a view display copy encoder. That's the Blick encoder we created. And if you click in this scene render command encoder, you'll see that the output from our first render pass is being used in our second Blick copy, which just copies straight to the metal drawable. And this is the back-end pipeline now. We're now drawing to some textures and then drawing those to the screen. All right, so now just to prove to you that this is a global texture that we can use on anything, let's go ahead and go into our quad, and right under here, I'm gonna say use base color texture, and we're gonna use that color render, okay? Now, when we use this color render, this is going to go into our shader and now use it where we pass in a texture. So it's now a texture. That's all it is. We're gonna pass it into our fragment shader now as this quad use this texture. Now in order for this shader to read this texture, we need to go back to our renderer and apply one more usage. So we can do comma right here, and we need to also do a shader read. If we don't add this, it's gonna blow up. And so add shader read. And so now we are able to use this texture anywhere. So let's go to our forest scene, and down at the bottom, add quad. I already did it for us, and what I'm also gonna do is I'm gonna say quad.move on the Z direction. Let's go up by 1.0. Obviously I need to do Y here and not Z. I'm just gonna move back into the scene. Let's do quad.move Y up 5. And it's probably way up in the sky. Yep, there it is. Let's go up to it real quick. So I need to go here and then press up. And look at that. And we get some weird artifacts, but that's okay. That's just, you know, we can fix those. It probably has to do with the depth buffer. When we do this render, we shouldn't be using the depth buffer for that texture, but regardless, it's somewhat working. And honestly, it might be the texture coordinates. That looks like, or it could be the reflection of a reflection of a reflection, and who knows? But it's working. We have a quad that's rendering our scene, and we have a texture that has our scene. Now at the very beginning of the episode, I also told you can render to multiple color attachments. Say we needed to render to a texture, so we get like the base albedo color, but we also need maybe the normals, right? So we need a texture with normals on it. How do we render to two places at one time? That's not hard. Let's go back to our renderer and create another texture that we can render to for the color attachment 2. Let's jump to our texture types. Go to base color render, and I'm gonna refactor that and rename it, I don't know, _0, because technically base color render is not good enough of a name. This is gonna be base color render at attachment 0, and then I'm also going to have a case render at 1. So now this will be the second render attachment. So we'll have 2 color attachments we can render to. Let's go back to our renderer function. I'm just gonna copy the base color texture, and I'm gonna paste it right underneath itself. Let's make this base color 0. This will be base color 1, like index 0, index 1. These will have exactly the same properties, that's fine. This will be base 1, base 1, base 1, and this will be base 1. Okay, just make sure you rename all those correctly. This one will also need base 0. I'm just going to rename these to base 0, base 0. That's already 0. And now we have a second texture that we can draw to. So let's scroll down here. Let's add it. First, we need this render pass descriptor to know about this second texture. So all we have to do is the same thing as before. Instead, we're going to use assets.textures at base color render 1. And yeah, now we're able to draw to a second texture at the exact same time. There's one more thing we need to do though. Our render pipeline state is going to freak out. It has no idea that this thing exists. So what we need to do is we need to go inform our render pass that it exists. So let's go to graphics, libraries, and let's just update our render pipeline state to now take in a second color attachment. So now it'll be able to say, oh yeah, this is what the color attachment for pixel format for this is. So you have to define these or else it'll complain at you, and we don't want that. So I'm just going to add it on all of them. And then we are ready to go. I mean, if I press play right now, our scene is going to render exactly the same. And in fact, I'll do that just so I can show you behind the scene that we've created a place to render more stuff. So there's our scene. Press the camera, go to base command buffer. Now you'll see we have 3 images. Look, we have 0 and 1. Now we're not actually sending any information to the number 1 yet, but we will. We can send that right now. That's just going to be a little bit of a modification to our actual shader. So let's go into our shader and output to 2 places. So what I'll do is I'll go to our shaders here, graphics, shaders. Let's just do the basic shaders for now because it's easier. And up at the top, I'm going to create a struct. This struct is going to define 2 different places. So we will say struct, and we will call it the frag output. And the fragment output will have 2 things. It'll have a half for color at 0, and we will say half for color at 1. Now you can name these whatever you want. If you want to make this albedo, normal, whatever you want to do, you can. I'm not going to stop you. But now we have a fragment output that has a color 0 and color 1 defined. We just need to add some attributes. So color at 0 will be pointed to color at 0, and color at 1 will be color at 1. And that's it. We now have a struct that points to 2 separate places. Done. Make sure you don't forget these attributes. It will not work if you don't have them. So let's go down to our fragment and now use that new frag output. Instead, it's going to probably complain because we're returning just 1 value. We need to return a frag output out, and we will say out.color0 equals, and let's make it equal to this right there. And we will say out.color at 1 will equal, well, we have a normal, I think. So we have this unit normal. Why don't we just say float 3 unit normal right there and output that. So right here we will say equals half for unit normal 1.0. Now of course this doesn't work. You can't just say unit normal just because it's a float 3. We have to do x unit normal.y unit normal.z. And then our output needs to change to our out. Cool, so now our fragment shader, our basic fragment shader, our sky sphere shadow shader doesn't do this. Nothing else will do this, only the ones that we define. So in this case, it's just the basic fragment shader. We've defined 2 different outputs. Let's run this and see what this looks like. Okay, everything's the same. Let's go behind the scenes and check out our frame buffers. Open up base command buffer, and now you'll see we're rendering normals. Look at that. Look at our normal map being outputted. Now we can use this to do whatever the hell we want. We can read, oh, it's so cool. I hope you guys see the value in this. Let's go ahead and instead of using this texture as our scene, let's try to use the other texture. So what I'll do is I'll go back to renderer, and I will go down here and I will say base color render at 1 instead of 0. And now we should be seeing a normal mapped texture. Heck yeah. So these are all the normals. One other thing you're going to notice is while we're scrolling, look at this. This is wild. And there's a reason for this, and I can show you how to fix it. This is the result of storing the pixels between renders. Every single time we draw, we never clear. So what we need to actually do is we need to go into our renderer, and we need to go modify color attachments at 0. So let's go here and we will say self.baseRenderPassDescriptor.color attachments at 0, and then we need to make the store action color attachments at 0. Dot store action needs to equal dot store. Okay, and the clear action, so I'm just going to copy this, needs to be clear. So we can say the clear action, or sorry, the dot action, the load action. I'm sorry, the load action is dot clear. So anytime the shader loads up the image, it's going to clear it. And here we are saying that we want to store this just like so. And then we need to copy that also for this one. So at one. Let's go ahead and press play and see our beautiful work. And if I were to look around, as you can see, each frame it's clearing. It looks a lot better. If I were to go up into the sky, you'll see all of our cool normal mapping done to this scene. Man, that's cool. Now, obviously, this is not the result we want. So what I'm gonna do is I'm gonna keep all this in there for you. You can go read this on GitHub and check this out and try to imitate it. It's all yours, free. But what I'm going to do is I'm not going to draw using base color render 1. I'm just going to use 0 right there. And then I'll leave that normal one in there. Just why not? You know, it shows you how things work. It's not slowing things down, it doesn't seem like. So yeah, let's go ahead and press play and make sure everything's back to normal. And it is. Man, I hope you guys enjoyed that episode. If you got this far, good for you. You are one step closer to understanding how really cool graphics work in video games. So, if you like this episode, hit that like button, do the subscribe thing. I'd love to hear from you. I have a bunch of links down in my description. Go check those out. Yeah, have a good one, people.